Remember that problem that you had to do the exponential regression? Who knows, maybe that might be on slide. Okay, expo log 2. 2a and b. You guys know you can use your calculator for this, yeah? Then how did you do 2c and d? Because the a and b are the easiest ones to do without a calculator. Anyway, these are two very important graphs. I mean, four very important graphs in mathematics. That's why you have these graphs. Okay, why don't we do them then? Now, up until 2 years ago, they couldn't even use a calculator to draw these graphs. And then now that you have a calculator, you guys can punch that in, right? You could actually punch in the hyperbolic cosine function too, you have it on your calculator. Anyway, this is what we had to do in the past, just to show you. Do we know how to graph this? Yeah. Do we know how to graph that? Yeah. And then do we know how to take an average? If you add two things together and divide it by 2, it's just taking the average, right? Okay, so what does e, and you better know the graph of e to the x. That's, okay, you're going to have two graphs tomorrow, right? One is e to the x, and you're going to do stuff to it, and the other one is y equal natural log x, and you got to do stuff to it. And then you're going to do u substitution, you're going to have to factor. And I haven't decided the other one or two problems. Anyway, e to the x, here's the point 0, 1. E to the x looks like this, right? What does e to the negative x look like? What happens when you substitute negative x for x? It reflects it over the y-axis. Okay, now all you have to do is, at each value of x, you add the two y coordinates and divide by 2. Basically, take the average. So, what is the average of 1 and 1? 1, right? And then for each value of x, here, if you draw vertical lines like this, how do you take the average? Don't you go halfway in between? Right? Like if you have one test that's an 80 and another test that's a 90, isn't the average 85? You go halfway in between. So you just draw these vertical bars and you just go halfway in between. So if you connect all the dots, what happens is you get a graph that looks something like that. Or even if you just have to plot points, right? I mean, that's what your graphic calculator does, basically, right? It just sweeps from left to right and plots points. Anyway, this is a very important graph. This is the hyperbolic cosine function. This is the hanging chain. You guys in physics know this, right? Like if you have a chain and you attach it at the ends and you just let it hang, what shape is that? Is that a parabola? No! It's a hyperbolic cosine function. Look, it's right there. In fact, you can impress your physics teachers if you tell them that. If you just hang something, a rope or a chain, it's not a parabola. It's a hyperbolic cosine function, or we call it a catenary. You heard that word before? Okay, impress your physics teacher. Anyway, the other graphs, just use your calculator. And then what about C, the bell curve? Well, first of all, you can see if you plug in negative x for x, the function doesn't change, so this is going to be an even function. It's going to be symmetric about the y-axis. And just plot points. What happens when you plug in 0? You get 1. Okay, here's the point 0, 1. Now, what happens when you plug in bigger and bigger numbers for x, like 1, 2, 3, 4, 5? What happens? What is e to the negative 1? Are you serious? Plug in 1, e to the negative 1. 1 over e. It's about 0.367 around, okay? And then what happens when you plug in 2? E to the negative 4. Oh, it's even smaller. What happens when you plug in 3? It gets even smaller. So what's happening is you get a graph that looks like this. And this is the famous bell curve that we learned in pre-algebra when you learned statistics. And you know what? You guys really never heard of the bell curve before? What if I were to compute the area under the bell curve? You know what it would be? Anybody? I'll give you free candy. You can tell me. And notice that this graph goes on forever now. What's the exact area? Well, it would, yeah. It's 1 when we adjust the coefficient over here for statistics. But since there's no, the coefficient is 1, I'll just tell you, nobody's going to get candy. Square root of pi is the exact area right there. And then D, did you guys draw the graph? What happened on that graph? What happened? Didn't it look something like this? Well, first of all, here's a question I gave on the quiz one year, I remember. You have this graph, 0.9x. As x approaches, okay, let me ask you this. What are the horizontal asymptotes of this function? What happens when you plug in a really big number for x? Like a million, billion, trillion. What happens to this? That's the key right there. What happens when you plug in a really big number for x? You get e to the negative really big. What is that? Isn't that very close to 0? So if this gets closer and closer to 0, what happens to the whole thing? It gets closer to 3 over 1 plus 0, which is getting closer and closer to 3. So what happens is the graph goes on to the right, it gets closer and closer to y equal 3. What about going to the left? What happens when you plug in a really big negative number for x, like negative million? Oh boy. What happens when you plug in, okay, what is negative 0.9 to the negative huge, like negative billion? Yeah, it becomes really positive huge, right? And what is e to the positive huge power? Very huge, even huger. So doesn't that mean, so what happens when you get 3 divided by a really huge number? 3 over a billion. It's close to 0. That's right. So when the graph goes out to the left, it gets closer and closer to 0. And you can see over here that what's the y-intercept? If I plug in 0 for x, you get 1. Okay. So this is what happens. The graph goes like this. This is called logistic growth. See, a lot of, exponential growth like this. Oh no, it's like this. Exponential growth. Real populations, they don't really grow like that, yeah? Like, you guys ever heard of Drosophila flies? You guys did this in biology. Oh boy. How about the seniors? Drosophila flies. Flies, not fries. Flies. Anybody taking biology? No. Okay, let's say you have any animal population or whatever. Okay, bacteria, whatever. Do they keep growing exponentially? No, because of resources and things, then the population kind of slows down, right? So real populations don't grow like that, but they do grow like this, right? So it grows exponentially for a while, but then it kind of levels off after a while. And so that's an important concept, logistic growth. That's why I put these graphs on, because when you go to calculus or higher science or math, you're going to see these in there. Okay, number 3, Lomi. Okay, this is on tomorrow's quiz. Okay. You got to be able to Lomi. You might even have to Huli tomorrow. Didn't we go over this example? Oh my gosh, and this example is like way easier than any of the ones we did on the board. Oh my lord. We're in deep trouble. Okay, what do you have to know for this problem? The limit as n approaches infinity of 1 plus box over n to the n is equal to e to the box. You have to know this. Okay, so let's look at this problem. I don't think you even have to Lomi, just gotta do tiny Lomi, mini Lomi. This is like, okay, this is what you have to do. Okay, so what you gotta do is you gotta make this look like this. So all you have to do is do this, and put the 2 on the outside of the brackets. The one we did on the board was way harder than that. Because look at the brackets, 1 plus box over n to the nth power. If you take the limit as n approaches infinity, the thing in the brackets gets closer and closer to 1 plus box over n to the n. As n goes to infinity, it gets closer to e to the box. Here, look, box. Maybe if I put the box there. Oh, now I get it. So, the thing in the brackets gets closer to e to the third. But then you gotta square it, and so it gets closer to e to the sixth. There's hardly any loaming. There's no hooliging in that. Tomorrow you better hooly and loamy. You better look at those examples I did. Maybe you gotta look at the video again. And then, oh no, 4, what does that say? 4, 7b? That doesn't even make sense. 47b? Or does that mean 4 and 7b? But 4, there's part A, B, C, D, E. Okay, tomorrow, these are 2 of the problems on the quiz, okay? I'm just telling you the whole quiz. It's up to you if you want. One of the graphs is e to the x, and then you gotta do stuff to it. The other one is natural log x, and you gotta do stuff to it. Okay, why don't we just do it? Let's do them all. Whatever. Okay, what's the base graph of this? E to the x. Okay, that the key point is 0, 1, and of course e to the x looks like that. Okay, now you gotta do stuff to it. What does that minus 1 do? It shifts it 1 to the down. So everything comes down 1 unit, so that means the horizontal asymptote is going to be at y equal -1 now. So it looks like this. And then what happens when you put absolute value in the whole function? Everything below the x-axis gets reflected above. So now this asymptote goes up there, so it's going to be y equal 1. So this part here stays that, but then you got to flip it over the x-axis, so it's going to look like that. Are you guys checking these on your graphic calculator? Or you think me drawing it on the board, that's your graphic calculator? That's the way it's going to be, yeah? Okay, again, the base graph is e to the x, which looks, here's the point 0, 1. Okay, there's 2 things going on. You got this, and then you got this, right? Which one do you do first, or does it matter? Sometimes it doesn't matter. Does it matter which one you do first? This reflects it over the y-axis. This means erase everything to the left of the y-axis, keep and reflect. Does it matter which one is done first? Yes! Which one is done first? No. Okay, if you do that, no. You guys. Okay, if you do the absolute value first, okay, erase everything to the left of the y-axis, keep and reflect. And then, if you want to reflect it over the y-axis, you got to substitute negative x for x. Is that what it says there? No, so you don't do that. Okay. So, reflect it over the y-axis first, and then if you put absolute value only on the x, that means erase everything to the left of the y-axis, keep and reflect. Is that the same as that? Yes, so that's what you do. This is not the same as that, so you don't do that one. Okay, some of you are still confused on which one you do first, whichever one the problem calls for. That's what you do first. So the first thing we do is reflect it over the y-axis, which looks like this. And then now, everything to the right, erase everything to the left of the y-axis, keep and reflect the remaining portion about the y-axis. So it's this thing right there. I thought we cleared that up when we studied functions. No, it's still kind of foggy this part. Are we really doing these all? Are we really going to finish the charade? Okay, let's finish. Okay, what TV show is this then? Okay, what's the base graph? Y equal natural log x, with the key point is 1, 0, it looks like this. It's the inverse of e to the x. Okay, now do stuff to it. What does that do to the graph? It shifts it 1 to the left, so this point comes here, now the vertical asymptote is here, so it's like this. Label, x equal -1. And then what does absolute value around the whole thing do? Everything below the x-axis gets reflected above. So the stuff that's above the x-axis, you leave it alone! But everything below, you negate it so it gets reflected above. Like that. Now this one, did the order matter? Could I have done the absolute value thing first and then shifted to the left second? Yeah, so this one, the order didn't matter, but some of them, the order does matter. Again, two things going on. This one reflects it over the x-axis. This means erase everything to the left of the y, keep it reflect. This one, does the order matter? Does the order matter? Just think about it. Okay, look. What you made me do? Okay, here's natural log x. Think about it. If I reflect it over the x-axis, and then erase everything to the left of the y-axis, keep it reflect. What if I erase everything to the left of the y-axis first, keep it reflect, and then reflect it over the x-axis? Do you get the same graph? I don't know, what did you just say? Okay, look. Reflect this thing over the x-axis, so now the thing looks like this. Now, erase everything to the left of the y-axis, which nothing is there. Keep and reflect the remaining portion about the y-axis. That's your graph. Okay, now what if I did the other order? What if, okay, here's the original graph. What if I erase everything to the left of the y-axis, keep and reflect the remaining portion about the y-axis, and then you reflect it over the x-axis? Do you get the same graph? Yeah, so this one, the order doesn't matter either. And then here's E. This is like, I don't know, this is like the 10th time we've done this one. Oh boy. Okay, draw the base graph. Maybe I might have PD on you tomorrow, and if you just draw the base graph, maybe I'll give you 1 point. Or maybe I won't. But at least draw it in. You just never know. Okay, this is the same thing as negative x plus 1. Two things going on. Reflect about the y, and then x plus 1 means shifted 1 to the left. Which one is done first? This one, the order matters. Which one do I do first? I've been giving you this, I don't know how long already, since functions. We did 3 or 4 times during functions. Oh my goodness. So which one do I do first? Here, maybe some of you got to just resort to memorizing already. Reflect or shift? Shift is done first. Because look, if you go backwards in the alphabet, S comes before R. So it's SR. Sunrise then. Here. Remember this. You guys need something to remember? This is no teacher would resort to this, but here, sunrise. Not rising sun. It's sunrise. So you shift it to the left, 1. I can't believe that's the first time I've ever done that in the history of calculus. You shift it 1 to the left. Now you reflect it over the y-axis, so that means this vertical asymptote is down here. So what would happen? If you reflect this still on the graph, it's going to look like this then. Live action. So did we get these graphs? Or are we just furiously scribbling now? Oh no. Yeah, I can see that. I can see a blank page. Okay, so that's 2 of the problems, and then we're going to have 1 U substitution, 1 factoring. So that's 4 problems. Oh, and then lomi, you might have to huli, the limit one, 5. So at the most, there can only be 1 more problem. Well, I don't know. Could have 2. What would it be? Could it be this number 6 from expo log? Here are your candidates then. Here, you want to just write them on the board? Do your chemistry teachers do that? Oh, can you tell us which problem to study for the quiz? I'm not doing it. Okay, let's just finish this up. 7B. Say what? Maybe we should do, wait, how can we not do 7B but we can do 7A? That's the strangest thing I've ever seen. Should we do 7A and 7B? You sure? I think we should. We are going to do it. Because now I'm thinking one of these is going to be on tomorrow's quiz right there. Okay, how do you find the inverse of anything? E to the x, where's the plus 1? It's over here. How do you find inverse? What do? You switch the x's and y's. How many points do we get for this, Mr. Park? Nothing. If you don't know how to switch the x and y, it's too bad. Just go home. Right? Okay, now you got to solve for y. Now, how do you solve for y? Subtract 1. Now what? You natural log. Well, there's two ways of thinking about it, okay? Your teachers last year told you just change it from exponential form to logarithmic form, right? Remember I told you that's the key to working with logarithms? If you see log base b of a equals c, what does that mean? B to the c equals a. This is the key. Just go back and forth between the two. So if you have exponential form, which is this one, change it to log form. So how do you change this to log form? Log base e of x minus 1 is equal to y, right? Because e to the y equals x minus 1, right? Except we don't write log base e. What do we write? We write natural log. So this is the same thing as y equals natural log x minus 1. So that's how your teachers taught you last year, right? Just change it to exponential form. Okay, but here's another way of thinking about it. If you want to get rid of this e, you do the inverse, you natural log. So what you do is you natural log both sides. Natural log of x minus 1 equals natural log of e to the y. But what is natural log of e to the y? It's just y. Why? Because we took the turn. Remember, what's the I wrote this down last week, but obviously we don't remember. What's the relationship between this graph and this graph, log base b of x? They're inverses of each other. So if two functions are inverses of each other, what happens when you plug one into the other? You get x. So if I plug this into this, you get b to the log base b. You remember me writing this on the board last week? And then if you plug this into this, you should also get x. So log base b of b to the x is equal to x. Here, I'll box that because that's in your notes. Super important. And that's why natural log of e to the gorilla is gorilla. Because look, natural log just means base e. It doesn't matter what base it is. So natural log of e to the gorilla is gorilla. You guys get it? It doesn't matter what base you use. So so if you want to get rid of e, you just natural log both sides. I mean, it's the same thing as changing the exponential form, but it's just a different way of thinking about it. Okay, I'm going to leave that on the board there. Okay, now let's do b. How come now some of you going, oh, and then you guys never write 7a on the board? How do I come? You don't answer.
Sorry.
Okay, how do you find the inverse?
I didn't write that.
I stopped listening. Okay, so you switch the x's and y's. Okay, now how do you solve for y? Well, the way your teacher taught you last year, change it to exponential form. What's the base here that's not written? E. So e to the x equals this, right? So e to the x equals this. And then to solve for y, just subtract 2, so you get e to the x minus 2. There's nothing wrong with that. We learned that last year, but I'm just going to give you another way of thinking about it. If you want to get rid of ln, you e both sides. So if gorilla, in other words, if gorilla equals banana, then therefore e to the gorilla got to equal to e to the banana, right? So you get e to the x equals, and what is e to the natural log of armadillo? Armadillo! So to solve for y, you just subtract 2 from both sides, and there's your answer. So, here, let me put it together for you. So if you want to get rid of an e, you natural log it. If you want to get rid of natural log, you e it. Because they're inverses of each other. Or if you don't like what I'm doing, then just change it from exponential to logarithmic or logarithmic to exponential form. They both give you the same result. You guys know what I'm talking about? Well, the main thing is you can do it, right? Sunrise. And then number 8. Okay, no, I think this one's gonna be on the quiz. I can't decide. Okay, part A. Are we doing all of it? Yes. Why even love that? Okay, when you have a logarithm, it doesn't matter what kind of logarithm it is. How do you find the domain? Okay, well let me draw the picture for you. Here's the graph of y equal whatever, natural log x, okay? What's the domain of this function? What's a listing of all the x coordinates on this graph? X is greater than 0, right? So whenever you have a logarithm, this thing here, the argument, has to be greater than 0. So, I see over here, natural log gorilla. If I want to find the domain, then gorilla has to be greater than 0. The argument has to be positive. I thought your teachers drilled that into you last year. But it doesn't matter, I'm drilling it into you now. Anytime you have a logarithm, this argument has to be positive. Because there's no such thing as log of 0, right? Here, think about it. Natural log 0, what number is that? E to the what power equals 0? If you can give me an answer, I'll give you all the candy in my desk. E to the what power equals 0? 0? No, e to the 0 is 1. There is no number. It's undefined. That's why whenever you have a logarithm, the argument has to be greater than 0. You solve this inequality and that will be your domain. Do we know how to solve inequalities? We should be experts because we just had a test. We just studied it a couple chapters ago. How do you solve inequalities? Make one side 0, which it is. Factor this side, which it is. It's all like ready-made already. Now you test the number line. What goes on the number line? What makes the top or the bottom 0? Negative 1 and 1, no and no. And how do I know this one's going to be minus plus minus? Okay, okay. Or if you don't know anything, plug in a number bigger than 1, like 2. 1 plus 2 is positive, 1 minus 2 is negative. Positive over negative is negative. And then once you get that, then how do I know they alternate? Because they have odd powers. And even if you don't know that, just plug in a number here like 0 then. 1 plus 0 is positive. 1 minus 0 is positive. Positive divided by positive is positive, right? Even if you don't know anything, you can still do the number line, right? Unless you don't know positive, then positive is positive. Then you're going to have trouble. And then B, find the inverse. Okay, now, after the explanation, this should be really easy. How do you find inverse? You switch the x's and y's. And then now you got to solve for y. But in order to do that, you got to get rid of ln. How do I get rid of the ln? You e both sides. If gorilla equals banana, then e to the gorilla equal e to the banana. So you get e to the x equals, and what is e to the natural log? Aardvark. Aardvark. See, you guys got it. As long as they use animal names. And then now, how do I solve for y, Mr. Park? What do? Do I lift and separate? No, you cross multiply. So you cross multiply. Are you writing this down on Alpha?
Yep.
Put all
I'm on that area.
put all the y's on one side, factor out the y. This is just algebra. And then divide. So y equal e to the x minus 1 over e to the x plus 1. The e to the x's cancel out, the 1's cancel out, so you get negative over positive, which is negative. I don't know what to do with you. Okay, are you sure there's no more questions? Okay, so use substitution, factoring, e to the x graph, natural log x graph, find the domain, find the inverse, 6 problems, and then the limit, the one lomi. So that's 7 problems. So 3 points each, -1, 3 points. I keep giving you so many free points. But then what about this graphic calculator one? I like that one. Exponential regression. We just don't have room for it. I don't know. Bring your graphic calculator anyway, because you might have to do the exponential regression. Mm-hmm.
How come when you plug in natural log into the graphic calculator, it stops giving you y coordinates?
Say what, girlfriend? Isn't good. Just stops.
Yeah,
Just
like
the y.
it stops.
Are you actually tracing it?
Yeah.
I don't know. You guys understand her question? Here's the graph. Okay, she's graphing natural log x on her calculator like this. So when she's tracing the graph, when she gets like over here, what was it? X equals 0.4 something.
Yeah.
Then it doesn't give the y coordinate. But it should. Because that number is not that incredibly small. I don't know, why would we need that though?
I don't know, I was just wondering.
Oh, I don't know. I'm befuddled by that. Because sometimes if the number is either too small or too big, then the calculator has trouble crunching those numbers. Yeah, but natural log of 0.4 something is not that small. So yeah, I don't know. Okay, today is the last lecture. So that means isn't there 2 practice tests? Full log 4 and 5, those are 2 practice tests. Yep. Okay, so today we just gotta go over your 3 properties of logarithms and the change of base formula. That's all you need to know. And then you just gotta practice getting used to these. Okay, let's go over the 3 laws of logarithms that we learned last year. I don't know, for some reason every year the students remember these. Log base b of m plus log base b of n is equal to log base b of what? mn. You guys are used to seeing it the other way? Doesn't matter which way I write it? Okay, here. Let me erase. This is the way that most folks write it then. Log base b of m times n is equal to log base b of m plus log base b of n. Duh, it doesn't matter, right? A equal b, b equal a. Well, I just write it because that's the way it is, right? Log base b of m divided by n is equal to? Okay, m minus log base b of n. Log base b of m to the nth power. Yeah, you just put the power in the front, right? Remember that one? I think Mr. Rubar says cough up the hairball. You guys remember that? Cough up the hairball. I don't know what that means. If you have something to a power, you put the power in the front. Why is it? I don't get it. Like, this is like the hairball in the throat of the cat. And then you cough it up, like, in the front. Is that it?
Yeah.
How do you know that's the head? What if the head is on this side? Then it's not cough it up, it's like, well, poop it out, right? How do you know which side is the head? Anyway, these are your 3 laws of logarithms right there. And then the change of base formula. Because, for example, if you have a logarithm that you just can't work with it, then you can change it to a different base. So, log base b of a is equal to, let's say you don't like base b, you want to change it to like base c. So, log base c of a all over log base c of b. This is the change of base formula. It's easy to remember because look, the top one goes on the top and the bottom one goes on the bottom. What could be easier? Rising sun! No, that's the wrong one. That's the wrong one. Sunrise! You guys better remember that tomorrow. You're probably going to have the sunrise tomorrow. Okay, these are on your notes. Okay, so what kind of problems can you expect to see on the homework? Well, things where you got to use your rules of logarithms, like this. Solve this equation. Solve for x. Log base 8 of x plus 1 plus log base 8 of x plus 2 minus log base 8 of x minus 3 is equal to negative 2/3. Just make up something. Okay, how would I solve a problem like this? Factor out the log base 8. Don't you dare do that. This is not times, that's why. A lot of people think it's log base 8 times x. No, it's log base 8 of x plus 1. That's the argument. So what you do is you use your properties of logarithms. So what happens when you add the logarithms are added? They're multiplied, the arguments are multiplied like that, right? And then when you subtract, yeah, it's divided. Can you guys do that all in one step? Okay. Now, why do I want to write this as just one logarithm? Because now you can get rid of the log base 8. How do I get rid of a log base 8? You ate it. What's funny about it? So, think about it. If gorilla equals banana, then 8 to the gorilla got to equal 8 to the banana, right? And what is 8 to the log base 8 of cheetah?
Cheetah.
It's cheetah. Oh, now I get it. And what is 8 to the negative 2/3? 1/4. And now you reduce it to an algebra 1 equation. So you combine all the logarithms together using your properties, and then you know how to get rid of the log, right? Okay, now how do you solve this? Cross multiply. So you have x minus 3 equals 4 times, let's see, x squared plus 3x plus 2. Distribute katize the 4. This is just all nonsense right now. 4x plus 8. It's a quadratic equation, so you make one side 0. So 4x squared plus 11x plus 11. Did I do that correctly? Was that factorable? Oh, I don't like this problem. Well, you see. Okay, so using the quadratic formula, x equals negative b plus or minus the square root of b squared, which is 121, minus 4ac, which is 176. So that comes out to a negative 25 all over 2a. We're only looking for real, we're not doing imaginary numbers here, so this one is no solution. So this is a bad example. Too bad. What would have done, what have, no, I'm gonna, for the next class, what would I have to do to make a better example? X plus 3. I need this number to be smaller or this number to be bigger somehow. What would make this number bigger? Whatever. The answer for this problem is no solution. Anyway, I just want to just make sure. What if, okay, let's just say, okay, what if the answers came out, okay, you solved the quadratic equation. What happens if the answer came out to like 5 and negative 4? Why do I cross out negative 4? Because remember, when you have logarithms, the argument has to be positive. So when you get your answers, you got to make sure each argument is positive, right? Like if I plug in 5 here, 5 there, 5 there, all positive, right? But then if you plug in negative 4 here, that makes them all negative, well, it makes them all negative, so that's why you got to cross that out. The domain of natural log banana is greater than 0. That's super important. Okay, now let's do a half-life problem. How many of you guys, most of you took chemistry already, or are you taking it now? You guys heard of carbon dating? Okay, carbon dating. Carbon dating. Okay, the half-life of radioactive carbon 14. Is it 14? That's an what's the normal number for carbon? 12. Okay, so this is an isotope of carbon is, I think it's about 5,750 years. You guys know what that means? It takes 5,750 years for us. Let's say you have 10 grams of this. It'll take this long to decay to 5 grams. That's how long it takes for half of it to decay. And then we use this fact to compute the age of certain things, yeah? You guys learned this in chemistry? What do you mean, no? When did you learn it then? It's not chemistry. Okay, anyway. Chemistry is elementary school. Okay, right? Oh my gosh, are we done already? Congratulations, Kareem.
I promise, I didn't write anything before.
Yeah, because you didn't do any homework.
I tried.
Too bad.
I tried.
We're done. And this is the class we taped, yeah? So nobody gets the carbon dating lecture. So good luck on your carbon dating tonight. I guess that's going to be on the board tomorrow, then, huh? We're in trouble!